Good morning. Happy Monday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to go on and cover section 5.6. But before we do that, we have some questions from you folks. So we'll take a look at those. Let's see, here we go. All right, so this is from section 5.5, number 20. As we see in WebAssign on the left side of the screen, consider the following drawing. It has a bunch of information that it says down part A. What is the difference in the length and width of the one-bedroom apartment shown below? Simplify your answer completely. All right, so the length equals what? A of x feet plus b of x feet. And we're told that a of x is x squared minus x plus 2. And then b of x is 8x plus 6. So if we add those together, we get x squared plus 7x plus 8. So that's the length. Okay, good morning. And then we've got the width. Let's see here. The width is what? C of x feet plus d of x feet, which is x squared minus 14x plus 2, and then plus 7x plus 4. Combining like terms, we get x squared minus 7x plus 6. But we want the difference. So we want x squared plus 7x plus 8 minus the quantity x squared minus 7x plus 6, which is going to give us x squared plus 7x plus 8 minus x squared plus 7x minus 6. Combining like terms, those would cancel and we get 14x plus 2, and that would be feet. So there's the answer to the first question. All right. Then it says, find the perimeter of the apartment. Well, the perimeter would be 2 times the length plus 2 times the width. So the perimeter would be 2 times the length, x squared plus 7x plus 8, plus 2 times the width, x squared minus 7x plus 6. So we're going to get 2x squared plus 14x plus 16 plus 2x squared minus 14x plus 12. Combining like terms, we get 4x squared plus 0x plus 28, and that is feet again. So there's the answer to problem number 20. Any questions on that before we go on? All right. Now,
no.
Okay, great. Now we're going to look at problem 21 from the same section. So this is 5.5, number 21. Here it says, the length of a fan belt that wraps around 3 pulleys is, it gives the total length. So let's see here what that is. That's 3x squared plus 18x plus 4.5 pi inches. Find a polynomial that represents the length of a part of the belt shown in the illustration below. All right, so we know the total length because it's given right here. And then we're given values for all the individual pieces except this one. So if we add together all the pieces that we know, and then subtract that total from the complete total, we'll get the missing piece. So let's see. How about if we start down here and we'll go clockwise? So we've got 2 pi plus x squared plus 5x plus pi plus x squared minus 3x plus 1.5 pi. Okay, so that's everything but the missing piece. So that's going to give us what? 2x plus x squared plus 5x plus pi plus x squared minus 3x plus 1.5 pi. Combining like terms, I get 2x squared, and then what? Plus 2x, and then 2 pi plus pi is 3 pi, plus 1.5 pi would be plus 4.5 pi, and that's inches. So now we've got the perimeter of the whole thing, and then the perimeter of everything but the missing piece. So we're going to take this and subtract it from that. So we're going to have 3x squared plus 18x plus 4.5 pi minus the quantity 2x squared plus 2x plus 4.5 pi, and these are all inches. So that gives us 3x squared plus 18x plus 4.5 pi minus 2x squared minus 2x minus 4.5 pi, which is x squared plus 16x, and the 4.5 pi minus 4.5 pi cancels. So we've got that many inches. All right. Now we've got another student's questions. One of them is the same question, but different numbers. Give me a minute here to get that set up. Let's see here. So. Okay. So this is also from section 5.5, number 21. And we've got some different numbers here, but the idea is the same. So the total perimeter is going to be what? 3x squared plus 17x plus 4.5 pi. And the pieces that we have here are going to be 2 pi plus x squared plus 5x plus pi plus x squared minus 3x plus 1.5 pi. And again, what did I do? Just walked around here clockwise, this plus this plus this plus this plus this, okay? Which is going to be 2x squared plus 2x plus 4.5 pi. So then we're going to have all of this minus all of that. So 3x squared plus 17x plus 4.5 pi minus the quantity 2x squared plus 2x plus 4.5 pi. I'm not going into as much detail this time because it's the exact same problem, just slightly different numbers. So this is 3x squared, lovely looking x there, plus 17x plus 4.5 pi minus 2x squared minus 2x minus 4.5 pi, which is x squared plus 15x, and that is inches. Okay, so there's that problem. And then the student asked for a problem that's actually from today's section, but we can go ahead and do it. find it here. Let's see. This is from 5.6. Number 23B. Let's see here. Okay, well, this is going to open a can of worms, but I'll go ahead and do it and for that student, and then we're going to go back and just do the whole lesson, which will explain how to do this. I usually don't do questions ahead of time, but we've got plenty of time today, so we're okay. So this is from section 5.6, number 23B. Okay, and can you see that on the screen? Did I open up the right stuff there?
Yes.
Okay, great, thank you. Okay, perform the indicated operations to simplify each expression if possible. If expression can't be simplified, enter so. All right, so what we've got here is 1/2 C minus 5D times 1/4 C plus D. And I'm not going to go through the entire explanation right now. I'm just going to kind of do the problem, and then I'll go back and we'll start over and explain everything. But to do this, we're going to multiply this times this, which is 1/2 C times 1/4 C, which is 1/8 C squared. Okay, then we're going to multiply this times this, which is plus 1/2 C times D, which is plus 1/2 CD. Then we're going to multiply that by that, which is minus 5D times 1/4 C, which would be minus 5/4 CD. And then we're going to multiply minus 5D times D, which is minus 5D squared. Then we're going to combine these two like terms. Common denominator is a 4. So this becomes that. I'm going to multiply 1/2 by 2/2, which makes it 2/4 CD minus 5/4 CD. So we get 1/8 C squared minus 3/4 CD minus 5D squared. And again, I know that's throwing a lot at everybody. Don't worry about it. We're going to go on and talk about how to do all that in this section today. All right. So now give me a second here. And I'm going to close that up and that up. And let's see here. All right. So now we should be back to my regular whiteboard screen. And we're going to take a look now at section 5.6. All right, we good? Can you see my whiteboard screen?
Yes.
Excellent. All right, so we've looked at polynomials. We've looked at adding and subtracting polynomials. So what's next? Multiplying polynomials. Let's say we have x times the quantity x minus 2. Well, distributing, we get x squared minus 2x. Let's say that in addition to that, we also had plus 3 times x minus 2. So then we get plus 3x minus 6. And if we were to simplify the whole problem, combining like terms, we'd get that. Any questions as to how I got there?
No.
All right, now consider this. X times x plus 2, excuse me, x times x minus 2 plus 3 times x minus 2. Isn't that the same thing as x plus 3 times x minus 2? We've got x times x minus 2 plus 3 times x. So x times that plus 3 times that is x plus 3 times that.
I'm not sure.
Not sure. Okay. All right. Let's go back. Let's see here. Easier just to start over, but then I'd forget what I wrote. Okay. Are you okay with where I got that?
Yes.
And are you okay with where I got that?
Yes.
Okay, let's come back to that. Let's say I had 2 times 7 plus 6 times 7.
Mm-hmm.
Wouldn't that be the same thing as 2 plus 6 times 7?
Yes.
You see it, you're sure?
I think so.
Okay, there's that I think so again. Well, this is 14 and this is what, 42, and that's 56, and this is 8 times 7, which is 56. So I mean, it works, but I don't think that's the problem. I think it's just you're not seeing. Oh, tell you what, let's do this. Well, let's go back here. And what did I have here? 8. Let's do it this way. What if I had 2 plus 8 times 7? Okay, or in fact, let's even write it this way. And I said, I want you to simplify this, but I want you to simplify it by distributing first. Ordinarily, you'd say, well, 2 plus 8 is 10, and 7 times 10 is 70, right?
Yes.
But what if we did it without simplifying inside first? What if we distributed? Wouldn't we get 7 times 2 plus 7 times 8?
Yes.
And isn't that the same thing as 2 times 7 plus 8 times 7?
Yes.
So what I'm doing is going from here to here, and I'm trying to get you to go from here to there.
Okay.
Trying to say that this is equal to that.
Okay, I understand.
Let's go back.
Took me a minute.
That's okay. It's okay. So what I'm saying here is that this plus this, which ultimately is that,
Mm-hmm.
is the same thing as saying x plus 3 times x minus 2. I've got x times this plus 3 times that, so I've got x plus 3 times that.
Yes.
Okay, now, instead of doing it in individual, oops, got the eraser still on there, doing it individual pieces, we're going to do it all at once. We're going to take x times x times minus 2, which is what we did right there, plus 3x minus 6, which is what we did right here. So then combining like terms, I get that. So I've got 4 products. I'm taking the first term over here times the first term over there. I'm taking the outer term here times the outer term there.
Okay.
I'm taking the inner term here times the inner term there. That's not how you spell inner, or is it? Yeah, it is. Okay. And then I'm taking the last term times the last term. This is called FOIL, first, outer, inner, last.
Oh, yes, I remember this.
Okay, all right. This is the big deal today. Okay. So let's continue on with the big deal.
All right.
We're now going to back up a little bit and just kind of review some things. If I've got 4s times s, that's 4s squared, right?
Yes.
If I've got negative 2a cubed times 11a squared, that's negative 22a to the 5th.
Yes.
That, okay. If I've got negative 2/3 x to the 6th times 9x cubed, I could reduce the 9 over the 3 to 3 over 1.
Mm-hmm.
And then I'd have negative 2 times 3, negative 6x to the 6 plus 3x to the 9th.
Yes.
Okay. Right.
Mm-hmm.
So that's just multiplying 2 monomials together. Now, what if I have 3a times a plus 2? So I'm going to distribute and get 3a squared plus 6a. Okay.
Yes.
What if I've got negative 4b cubed times 2b squared minus 2b plus 2? That's going to be negative 8b to the 5th plus 8b to the 4th minus 8b cubed. Are you okay with that?
Yes.
All right. So now, let's say I've got y plus 3 times y plus 5. So I'm going to take y times y,
Be y squared.
right? Y times 5 would be plus 5y.
Mhm.
3 times y is 3y. And 3 times 5 is 50.
50.
So we've done the FOIL. We've done the 4 multiplication thingies. That's a very math-related term. Combined like terms, y squared plus 8y plus 15, final answer. So we're multiplying two binomials together to get a resulting trinomial in this case.
Yes.
All righty. Let's take n plus 8 times n minus 10. N times n is n squared. N times minus 10 is minus 10n. 8 times n is 8n. And 8 times minus 10 is minus 80.
Yes.
Combining like terms, n squared minus 2n minus 80. And there's our final trinomial answer. All right, let's introduce a decimal. 2.6x minus 3 times 2x minus 1. 2.6x times 2x would be 5. Well, let's see, 2 times 2.6 is 5.2x squared. Are you okay with that?
Yes.
All right. 2.6x times minus 1 is minus 2.6x.
Mhm.
Minus 3 times 2x is minus 6x. And minus 3 times minus 1 is plus 3. Combining like terms, 5.2x squared minus 8.6x plus 3.
Yes.
All righty. Let's deal with some fractions.
Oh, my favorite.
Of course, just keep saying, fractions are my friend. Fractions are my friend. And maybe you start to believe. Okay, we've got 8t minus 1/2 times 4t minus 5/2. Okay. 8t times 4t is 32t squared.
Mhm.
8t times minus 5/2. So we're going to have minus 5/2 times 8t. And we'll come back to that in a minute. All right.
Okay.
And then minus 1/2 times 4t. And then minus 1/2 times negative 5/2. All right. So now 32t squared. The 8 over 2 is 4 over 1. So minus 20t. The 4 over 2 is 2 over 1. So minus 2t. And then plus 5/4, because negative times negative is positive and nothing reduces out. Okay.
Mhm.
Combining like terms, 32t squared minus 22t plus 5/4. fourths. Okay, let's take a look at this situation. And if I'm going too fast, say, hey, slow down. Okay,
Oh, no, you're fine.
all right. We've got s cubed minus 6 times s cubed minus 8. So foiling it together, s cubed times s cubed would be s to the 6th power.
Mhm.
S cubed times minus 8 is minus 8s cubed. Minus 6 times s cubed is minus 6s cubed. And minus 6 times minus 8 is plus 48. Combining like terms, s to the 6th power minus 14s cubed plus 48. All righty.
Yes.
Let's expand our horizons. Instead of multiplying two binomials together, let's multiply a binomial with a trinomial.
Okay.
Well, the idea is the same as FOIL, but there's 6 products instead of 4. So basically what we're going to do is start at the left and go to the right. So I'm going to take the first term over here, and I'm going to distribute it there, there, and there. Okay.
Okay.
This times this would be x cubed. This times this would be minus 2x squared. And this times this would be plus 3x. Then I'm going to move to the next term on the left. 2 times x squared is plus 2x squared. 2 times minus 2x is minus 4x. And plus 2 times plus 3 is plus 6. Combining like terms, those are going to cancel. So I'm going to get what x cubed minus x plus 6. And there's my final answer. Okay there.
Oh, sorry. Yes.
No, that's okay. It's all right. It's just you and me, so we'll go at your pace.
Okay.
Okay. What if we've got a trinomial times another trinomial? Well, it's going to be the same idea. Okay. We're going to have, let's see, w squared times w squared would be w to the 4th power. W squared times minus w would be minus w cubed. W squared times 3 would be plus 3w squared. Okay.
Okay.
W times w squared would be plus w cubed. W times minus w is minus w squared. And w times 3 is 3w. Let's see here. Let's go with green. 9 times w squared is minus 9w squared. Minus 9 times minus w is plus 9w. And minus 9 times 3 is minus 27. Okay. Now, combining like terms, I have w to the 4th power minus w cubed plus w cubed would be 0w cubed, so I don't need to put anything there. 3w squared minus 1w squared is 2w squared. Minus 9w squared is minus 7w squared. All right. 3w plus 9w is 12w, and then minus 27. Let's see here. Any questions there?
Nope.
Right. Now we're going to do multiplication using vertical form. Woohoo!
Oh,
Good times ahead. I knew that you were excited, but I just went ahead and spoke for you there. All right. We've got x squared minus 2x plus 1 times x plus 2. What I find interesting is when we just do arithmetic multiplication, we do it that way. But yet doing it with polynomials like this, like this thing, it's just kind of awkward. It's like it's easier to do it horizontally there. But anyway, here we go. 2 times 1 is 2. 2 times negative 2x is negative 4x. 2 times x squared is 2x squared. X times 1 is x. X times minus 2x is minus 2x squared. What bothers me is we still got to put that sign in there. It's like, you know, it doesn't just come naturally. And then x times x squared would be what? X cubed. So then we've got x cubed. Those cancel. Minus 3x plus 2 as our final answer. So it works, but it's just a little trickier, isn't it?
yes.
Okay, now we're going to multiply 3 things together. 4x times 2x plus 1 times x minus 2. What we're not going to do is we're not going to take the 4x and distribute it here and here and here and here. Okay.
Okay.
You only multiply 2 things together at a time. So what we are going to do is take this and multiply it by that, which is going to give us what? 8x squared plus 4x. Okay. Which is then this. And then we're going to take the result times that. Think about if I have 2 times 3 times 5. I don't take 2 times 3 and then 2 times 5. Right? What I do is I take 2 times 3, get the result, and then take that times 5.
Yes.
So I'm taking this, getting the result, and then I'm going to take that times what's left. Does that make sense?
Yes.
Good, because that's my story and I'm sticking to it. All right. 8x squared times x is 8x cubed. 8x squared times minus 2 is minus 16x squared. 4x times x is plus 4x squared. And 4x times minus 2 is minus 8x.
Yes.
Combining like terms, 8x cubed minus 12x squared minus 8x. All righty, let's see here. How about this one? We good to go on?
Yes.
Okay, x plus 6 times x minus 2 times x minus 4. So I'm going to multiply together 2 things at a time. So I'm going to do the first 2 first, which is going to give x squared minus 2x plus 6x minus 12. But I'm going to simplify that, and I'm going to get x squared plus 4x minus 12. And then I'm going to take that result and multiply it by x minus 4.
Okay.
So I'm going to get x cubed minus 4x squared plus 4x squared minus 16x minus 12x plus 48. And then combining like terms, x cubed, those cancel, minus 28x plus 48. And notice I'm writing my answer in descending powers. That's one of the things we call standard form. If you've got a polynomial with just one variable, standard form, you write it in descending powers of the variable. Righty? Okay. Let's see here. Let's deal with some fractions again. We have 5c minus 2/5 t times 10c plus 1/5 t. Okay.
Okay.
So we're going to FOIL. 5c times 10c is 50c squared. 5c times 1/5 t, that's going to be 5c times 1/5 t, and we'll come back to that. And then minus 2/5 t times 10c, and then minus 2/5 t times 1/5 t. And you can do all the reducing and simplifying in your head if you want, but I'm just doing it a step at a time.
Okay.
So here the 5s would reduce down and we get plus 1ct. Here the 10 over 5 is 2 over 1, minus 2 times 2 is minus 4ct. Now, even though it's tc, I'm writing it in alphabetical order so that I'll recognize that these are like terms. And then finally over here, the 5s reduce, minus 2t squared. Combining like terms, 50c squared, and this is going to be what? Minus 3ct minus 2t squared. Oh.
Okay. I was like, wait, hold on. I had to look at it for a second. I was like, oh, okay.
I made a mistake. I made a mistake right here.
Oh.
Because, yeah, the way I wrote it out, it looked like they're different lines. Let me rewrite that, make that a little nicer. This would be, so this is times 1/5 t. Those 5s are on the same line.
Yes.
So my bad. Okay, so this is what? Minus 2/25 t squared.
Ah.
Yeah, because I crossed those 5s out. That was my sloppy writing that 1/5 t up a little high there. So that looks a little bit better. Sorry about that.
That's okay.
One of these days I'll get through an entire hour without making any mistakes. Yeah. All right, we okay with that?
Yes.
Now, speaking of mistakes, here is the common mistake that I see every quarter students making. Let's say I've got x plus 2 plus x plus 3. Okay, we'll call that part A. These are called lookalike sort of thing.
Mm-hmm.
Here we've got x plus 2 times x plus 3. And what they'll do is they'll take this problem and they'll treat it like that problem. Okay?
Mm-hmm.
They'll take this problem and they'll FOIL it together. That's not multiplication. That's just addition. Okay?
Yeah. Yes.
Here, it's multiplication. So be really careful about that to get the correct operation. All righty. That's, like I say, that's a mistake I see a lot of. People take this and this just sort of disappears and they turn it into multiplication. If you do the wrong operation, you get a malpractice suit against you, doctor.
Definitely.
All right. I think that's pretty much it. Okay. Just be careful and try and write neater than I do so you can read your own writing. I can probably say that every day. So tomorrow we'll be back with the special products, which is where we're kind of doing the same thing we're doing today, but there's some special cases we're going to look at. Okay. Otherwise, I will be back at 1:15 with an exciting office hour if anyone decides to show up.
I'm sure I'll be back.
Okay, and I'll stop the recording.